So we learned the first important formula about the equation. Right now, example, find. Oh, we also learn the slope equation. Find the equation of the line containing try this one for me. Okay. Please type your full name in the chat. I want to check your attendance. Thank you. Okay, now let me write down the answer on board. All right, so find the equation of line containing -1, 2, and 3, 4. All right, so for this guy, we know there's 1 point here, right? 1 point here, but we don't have the slope, right? We don't have the slope. So the first step, we're gonna calculate the slope, and otherwise we couldn't plug in this line equation, because this line equation need a point, right? A point and a slope, right? So let's take a look how to calculate the slope. So for this guy, we have x1, -1, y1 equals 2, x2 equals 3, y2 equals 4. Right? That means we're gonna plug in this formula, right? This formula, we have what? We have 4 minus 2, x2, 3 minus -1. And then this guy is 2, 3 plus 1 is 4, okay? It's 1/2. It's 1/2. Now, we got a slope and a point, right? Then we can plug in this formula to get the point slope form. So y subtract y1 is 2, m is 1/2, x subtract x1. x1 is -1. Okay. Got the point slope form. Of course, you can simplify it. Right? Because this guy point slope form. Point slope form. Okay. And of course, some of you guys would like to simplify the equation to general form or standard form. Okay. So if my math lab requires you guys write down in the format of point slope form, you guys need to write down as this one. Okay, as this one. If you want to write down as a general form, what are you gonna do? You just want to remove the fraction firstly, just times 2 for both sides. Okay, like we did before. Remove the fraction times the least common multiple. Okay, least common multiple. 2 where -4 cancel out. Cancel out. And then you're gonna remove the x and the 1. So if you remove the 1, subtract 1 for both sides. Subtract 1, subtract 4, subtract 5. Okay. And remove the x, subtract the x for both sides. Okay. So that is general form. And some textbook would like to refer this guy as standard form. Standard form, okay? Different textbook has different terminology to describe this line equation. Okay, line equation. Now I'm gonna give you guys another one, and I wish everybody gonna make it. Okay, so I'll give you another example. Find the equation that contains -1, -1, and that another one is a 1, 1. Okay, try this one for me. Okay, try this one for me. Okay, let me write down the answer on board. The same things, right? Calculate the slope my2 minus y1, x2 minus x1. All right. So we have here's x1, y1, x2, y2, right? Plug in, and you're gonna get what? X1 y2 is subtract y1 is -1, x2 subtract x1, that is 2 over 2 equals 1. Okay, 1 plus 1, 1 plus 1, right? So now you're gonna plug in one point. If we plug in this point and slope, right? To this equation, right? 1 point and 1 slope. Okay. So y subtract -1, m is 1, x minus -1. Right? And then we have y plus 1, x plus 1. Right? And that is what? That is point slope form. And some of you might want to transform to other form. So what are we gonna do? Subtract 1 for both sides. Okay, and then subtract the x for both sides. And this one we call the general form. Okay, general form or standard form. Okay, standard form. That's the end of this equation. Today we're gonna learn a new equations. Actually, it's about very special equations. Okay, very special equations. Now let's take a look. Theorem. Equation of vertical line. And this guy can be written down as x equals a. X equals a, where a is the x-intercept. Okay. Now let's take a look. The equation of vertical line. A vertical line. Okay. And we defined the equation of vertical line as x equals a. Okay, x equals a. What does that mean? Let's draw a picture. We have a here, and the vertical line just cross over a. Okay, that is the vertical line equation. X equals a. Okay, x equals a. And be careful. Okay, here is x equals a is not a. Okay, the equation said that is x equals a is not a. A is a value. X equals a, that is a line. Is a line. Okay. Theorem. equation of a horizontal line y equals b. Okay, yb is the y-intercept. Y-intercept. Okay, y-intercept. So that's the horizontal line. Horizontal line. Okay. Now let's take a look at an example. The first example is here. Find an equation of the vertical line containing the point containing the point 3, 2. Okay, so how to solve this type of problem? The first step, you guys can draw a picture. Okay. There's a 3, 2. Right? And you draw a vertical line. Goes through this point. And it's very clearly the x-intercept is what? Is 3, right? So based on definition, the vertical line is x equals 3. Okay, equals 3. Here, you can draw a picture. Here, I'm gonna teach you guys a trick. How to quickly get the vertical line equation. You just need to take a look at the x-coordinate of this point. The x-coordinate of this point is what? Is 3. That means x equals 3 is the vertical line. Okay, that's the trick. That's the trick. Okay, understood? If this point has x-coordinate 3, then let x equals 3. That is vertical line. Okay, don't give me the 3. Some students in the test just give me 3. That is a value. Okay, if you just give me a 3, that is a value. That's wrong. You need to write down x equals 3. That's the line equation. Make sense? Do you guys understand? X equals 3 represent the vertical line. 3 means a value. It's nothing to do with the line. Okay. So I'm pretty sure some of you are gonna make a mistake. Just say, hey, the vertical line is 3. That's a value. It's not vertical line. Okay. Be careful. Example 1. So example 2.
What about the 2? Does that mean anything?
Nothing.
Okay.
Now, find an equation of the horizontal line containing the points -1, 2. Okay. The same thing. How to find the horizontal line? The first way, you can draw a picture. Right? You can draw a picture. -1, -2, 1, 2. So -1, 2, -1. Oh, sorry, -1, -1, 2 is here, right? And then you're gonna have horizontal line goes through this point, and you can tell that y-intercept is 2, right? So based on definition, y equals 2 is horizontal line. Okay, and here's a trick, the same things. For this point, it's -1 and 2. If we wanted to find the horizontal line, we just needed to find the y coordinates, right? Y coordinate, that is 2. Just let y equals 2, and that is horizontal line. Okay, that's a 2. So let y equals 2. That's it. Very simple and straightforward. But the tricky part here is you shouldn't get me 2. That is y equals 2. Okay, y equals 2 is the horizontal line, not 2. 2 is a value. Okay. Now I want you guys try an example by yourself. Find the equations of vertical line and horizontal lines containing the point now I want you guys to find both the horizontal line and the vertical line that are containing this point. Okay, try it by yourself. Okay, now let me write down the answer on board. So for this type of problems, vertical line is what? Vertical line is x coordinated, right? X equals -2. And horizontal line is y equals -3. Okay, y equals -3. Don't give me -2 and -3. That's wrong. You should have given me x equals -2 and x equals -2. That is vertical line, and y equals -3. That is horizontal line, not a -3. Okay, not -3. Okay, so that's the things we learned. Now today we're going to learn some other stuff, graphing. As how to graph a line equation if I give you a slope and a point. Of course, if I give you 2 points, it's very straightforward to graph the line equation. You just need to draw 2 points, right? And then connect these 2 points. That's what we learned before. Today, I want you guys to be able to draw a line equation through 1 point and 1 slope. How to draw this type of line equation? Now let's take a look. The first example. For example, I give you guys a line that has a slope 1/2, and we have the point. That the point is 1, 2. Okay, 1, 2. Okay, so let's take a look. The first things, you should draw a point. Okay, that's very straightforward. You should draw a point 1, 2, 3. 1, 2, 3. You draw a point. Okay. Now, take a look. For m equals 1/2, the numerator is always about move forward or backward. Forward or backward. For the denominator is about upward or downward. Okay, so for the numerator, is always about forward or backward, and the denominator is about upward or downward. So here I don't want to try any downward. I would just want to try upward for the 2. Okay, upward for the 2. Okay, so here I just want to try the downward in case you get confused. Question. Oh, you mean upside down? Like a 2/1? No, like 2/2 is the rise to the ground. One rise, like you said, it goes one goes forward back. You go to the right or to the left, positive or negative. Equals directions, but the numerator is the one that controls vertical. Oh yeah. You're right. Yeah. Oh, you guys already know it, right? So that's great. That's great. I make a mistake. I make a mistake. Sorry. So I gave you guys A over B. The numerator controls the um, upward and the downward. Okay, so upward. And the denominator controls forward or backward. You are right. You are right. Makes sense to me. Yeah, pretty good. Pretty good. I really appreciate it. So let's take a look this example. This example. As we can see here, the denominator that is a 2, right? Is a 2. So you move forward 2 steps. Okay, forward 2 steps. 1, 2, right? 2 units. 2 units. And the numerator that is 1. So you're gonna move upward 1 step or 1 unit, right? 1 unit. So move 2 forward 2 units, 1, 2, move upward 1 unit. It's here. So that's the point we want. Okay. So the first step, you're gonna draw the 1, 2, and as a second step, you're gonna move this point forward 2 steps and upward 1 step. Okay. So connect these 2, you're gonna get this line equation or this line. Okay. Good job. Good job. When did you learn this such a thing? Sophomore. Good. Fantastic. Good job. Good job. The second thing, if m equals -1/2, and I still gonna give you this point. Okay, the same things, very similar, very similar. We have 1, 2, 3, 1, 2, 3. Okay, the first step, we're gonna draw this point. That is 1, 2. Okay. And you can tell that, this slope is negative. Okay, this slope is negative. That means what? We're gonna move backward 2 steps or 2 units. Okay, move backward 2 units. So move 1, 2. Okay, backwards because here is a negative. Okay, and then you can compare this guy. If it's positive, we're gonna move forward 2 units. Right? However, here is negative. We're gonna move backwards 2 steps or 2 units, and we're gonna move 1 unit upward. Is here, right? And then we connect these 2 points, and that is the line. Okay, this line. Okay, clear? Question?
I have a question. Okay, why is it not taking us to rise and round where negative rise would be -1, and then it would run from -1 to -2. Why is it like that? Would that be the same thing?
You want to choose -1. So you want to choose move forward for the 2, move downward 1 step. That's okay. But I want to unify the steps. Some of you may make a mistake when you do such a thing. Of course, you can do such a thing. You can move 2 units forward and then move 1 unit downward. You're gonna get the same line. You put the -1 to here. That means you move downward, okay? Downward 1 unit. And move 2 units forward, okay? You're gonna get the same line. Here, I wanna unify it. I only let the negative imposed on the denominator. I don't want to impose the negative on the numerator, okay? I just want to unify the steps. Then you can understand how to draw the picture. Otherwise, I'm gonna confuse you, okay? Does that make sense or not?
I'm just used to riding around and going to the -1, then going over to the 1.
Yeah, you're right. You can do such a thing like that. What's your meaning is like that?
Okay, do some negatives that are below the zero.
You
No, that's not what I was thinking of. So, what I was thinking of was the zero. I was looking at -1 point down the y.
Did you write it on the board? I understand what you're saying. I don't have. You can write down on the paper. Write down on the paper. Show me.
Like that. Well, the rise is negative, so it goes down, and the run is -2, so it goes over the -2 right here. Yeah, -2 like that. Yeah.
So you want to say you pick the -1.
But it would be a straight line, though. That's what we do below the x-axis.
So you're gonna pick the where's the 1 and the 2? You cannot go through this point. That's a mistake.
Oh, okay.
Yeah. You just pick 2 points from -1 and 2. That's wrong. That's wrong. Okay. That's the wrong idea.
I see.
Okay. Make sense? Okay. So now just follow my steps. Okay. Anyway, I'm glad that you offer your own idea, but that's the wrong idea. Just follow my idea.
I got it. Now I just didn't understand that first. I missed it all past it.
Okay. But you gave me such a good some idea. At least that's you have a lot of thought about these equations. I feel very happy about that. Okay. Okay, just follow my steps. If that is negative, and we're gonna move backward 2 units for the denominator, and for the numerator, we're gonna move upward 1 unit. Okay, so we get another point. Connect these 2 points, and we got a line. Okay. Now let's try another one. So How about m equals -1, p equals 2, 3? We're gonna take a look. For this guy, one, two, three. So the first step, we're still gonna draw a point, 2, 3. Oh, okay. 2, 3. Okay, so m equals -1. We can write down as -1 divided by 1. Okay. Yeah. If I give you guys an integer, you can always divide it by 1. So we have denominator, that is 1. Of course, we have negative. That means we're going to move backward 1 unit, right? For the denominator is here, right? Backward 1 unit. And the numerator we has 1. So upward 1 unit. Right? Then we can connect these 2 points. And that's the line equation. Okay. Now I want you guys to try this one for me.
On the exam or are we going to be asked to give the other points like within the using this way?
Other points.
Yeah, to say that.
If there's 2 points, then you can just draw 2 points.
Yeah, I understand that. But they give us 1 point and then like were they going to interact to give us another point on that line?
Yeah, another point. Then that's 2 points.
Okay.
Yeah, the same thing. Yeah. I plan to give you guys at the end of October. Okay, so for this guy, we have a slope is 2, right? So that means 2 over 1. So the first thing you can draw the 1, 2. Right. Since here is 2 over 1, that means denominator is 1. We're gonna move forward 1 unit. And the numerator, that's 2 units, is here. Okay, so if that is 4, we
It's backwards right now. It actually goes round over round.
because here it's positive, right?
So we use okay.
Positive always forward. I already unified the steps.
We want it to rise above. That's cool.
Above is always upward. I already say that. For the numerator, always upward. Okay. For the denominator can be forward or backward. If the there is a positive, that means forward. If that is negative, backward. Okay, negative, backward. For the numerator, always upward, never be downward. Okay, so I just unify these steps. So for example, here, I move upward, that is 1, right? And for the first example, upward, here is 1, right? And for this example, upward is 1, right? Always upward for the numerator. And for the denominator can be a backward because it can be a negative, right? Negative, for this case, is -1. So a negative move backwards 1 unit, okay? And for this case, this is positive. So the denominator move forward, right? Forward. So connect these 2 points. We get this line, okay? Get this line. Now I want you guys try the m equals -2, p equals 1, 2. Still use this point, but now it's a negative value, okay? Negative value. I think most of you guys should be able to draw this picture now. Okay, it's not too hard. Follow the steps. Now let me draw it. Okay. X and Y. And the first step, we're gonna draw the 1, 2. All right. And then for this guy, we can say, hey, -2 divided by 1. So we move forward, backwards 1 unit because here is negative. Backwards 1 unit is here. And upward 2 units. 1, 2 is here, right? 2 units. So connect these 2 points to here. Right? That's the line equation. Okay, I'm gonna give you guys the last example. The last example. Okay, try this one for me. -1/2. Yes. And I wish this time everybody gonna make it. Okay. Just follow the steps. Follow the steps. I think everybody should make it. Okay. That's a negative. That means for the denominator, we're gonna move backward, right? Backward. For the numerator, always upward, and the side only decide move forward or backward, right?
Okay, this one. Negative sign is there, that means that the operation is. But it would be backwards, it would be backwards.
You mean negative. Negative always about, yeah, operation, backward or forward. For the numerator, always upward.
Like your stuff, right? So the line is going to pressure this, no matter what. So if those numbers are both negative, it's going to be positive. So if one number is a negative sign up there, then your slope is going to look like this. So it's both positive and negative signs there.
The most key is when you put a negative slope, you either take the negative sign and put it on the top or the bottom. Yeah, if you put it on the top, it's gonna go downward. Put it on the bottom, it's gonna go upward.
Don't try to confuse him. Just let him consider.
I had to have the same.
Because if you put a negative in the numerator, that will be downward. I want to unify it. Because otherwise, you will feel confused how to put the negative. You put it on the numerator or the or denominator. Some students were gonna get confused. Okay. I just want to unify it. Just if that's a negative, just move backward. Okay, that's it. Will be very easy to memorize it. Okay. I know some of you guys already know it. You can put it in the numerator or denominator. Both of them should be okay. Okay. Very good. Now let me write down the answer on board. One, two, three, -1, 2, 3, -1, 1, 2. So here is 2, 1, right? That's the point. And here is 2. And also we have a negative side. That means we're gonna move backward 2 units. So backward 1, 2 is here. And the numerator is 1, upward 1. That is here, right? Then connects these 2 points. That's it. That's it. Okay. That's the last example. Some of you guys already noticed. If the slope is a negative, the curve always goes like that, goes down. If the slope is positive, the curve always goes up like that. Okay. So that's another important property for the slope. I think if you get it very interesting, you can take a look at the book that have more details. But for this class, I will only discuss about how to draw this picture. That's enough. Okay. How can I wrap it up class here? Thank you.